Welcome to the Mission Matters podcast, a podcast from Shield Capital where we explore the technical opportunities and challenges of developing and deploying commercial technology to national security customers. I'm Maggie Gray.
And I'm Akil Iyer.
And we are your hosts from the investment team at Shield Capital. All views expressed by the hosts and guests on this podcast are solely their own and do not reflect the opinions of their employers or investment advice. References to any securities are for informational purposes only and do not constitute an investment recommendation or offer to provide investment advisory services. In this episode of the Mission Matters podcast, we're joined by Andrew Puryear, the Chief Technology Officer, CTO of L3Harris. Formed 6 years ago from the merger of L3 Technologies and Harris Corporation, L3Harris is the sixth largest U.S. defense contractor. It builds a wide array of defense products, including tactical radios, night vision systems, electronic warfare systems, rocket motors, and much, much more. L3Harris positions itself as the defense industry's trusted disruptor, combining the reliability and mission understanding of a long-standing defense prime with the speed and innovation of a challenger. The strategy includes partnering closely with startups and emerging technology companies to accelerate capability delivery, break traditional acquisition cycles, and move new technologies into the hands of warfighters faster than the conventional defense industrial model. As part of this strategy, L3Harris established a strategic partnership with Shield Capital to gain access to disruptive innovators for technology transfer, teaming arrangements, direct investments, and partnered contracts. Since establishing this partnership, L3Harris has partnered with dozens of startups, including Shield Capital portfolio companies like CSATs, Overwatch Imaging, and Code Metal AI. Andrew joined L3Harris 3 years ago and has been instrumental in driving the company's trusted disruptor strategy and expanding its partnerships with emerging technology startups. Andrew has had a long career in the national security technology space, having worked as a technical leader at the Stanford Linear Accelerator Center, Sandia National Labs, MIT Lincoln Labs, MITRE, and Ultra Electronics, as well as serving as an engineering duty officer in the Naval Reserves for more than 14 years. Andrew is one of the sharpest thinkers in the defense technology ecosystem, and I have personally learned a tremendous amount from my conversations with him over the past few years about where the industry and technology is headed. In this episode, we cover everything from the future of technologies like electronic warfare, attritable systems, and generative AI in the national security space, to how startups should think about partnering with defense primes, and much, much more. Now, on to the conversation.
All right, Andrew, thanks so much for joining us today. Super excited to dig in. It's been awesome to get a chance to work with you over the past years here at Shield Capital. Let me start right now. You're the CTO managing an amazing portfolio across technologies, but you started, I think, on Vassar Street doing your PhD in electrical engineering at MIT, and now here you are, leading a lot of initiatives across a variety of technology domains, from the traditional communications realm to AI to the platforms and payloads and sensors that make it happen. Let me ask you, when you're not doing your leadership work and you do have a chance to get behind code or get on a chipboard, what gets you excited and what do you still want to do technically that maybe you don't have as much time for these days?
Yeah, it's a great question. So, back to my time in the Status Center there at MIT, I always loved that MIT was an integral part to inventing radar, right? And so, given those roots, those deep roots that MIT has in radar and today's current trends in artificial intelligence and machine learning, in my off time, I love, I build models, I fine-tune models that do everything from, hey, this is how you classify RF to generating novel waveforms, whether that's, radar waveforms or comms waveforms, that sort of thing. Just super exciting to apply something that was so important historically, a decisive factor in the winning of World War II, and applying modern technology to that space.
Andrew, are you a vibe coder at all? Are you using Cursor or anything like that?
Yeah, and I love the trend of vibe coding because it really does help accelerate workflows, right? And I actually tell every engineer at L3Harris that they should be looking for how to use AI-enabled tools such as Code Metal, which is a Shield Capital portfolio company. How do you use a tool like Code Metal to accelerate your workflows so that we can be more productive as engineers? Which, what we all want to do as engineers is deliver capabilities to the hands of the warfighter faster. Right. And Code Metal allows us to do that. And, sort of the vibe coding ecosystem allows, engineers, non-engineers alike to start to build code. in terms of, whether vibe coding is high quality or not, you see various studies that have somewhat mixed reviews, right? But one of the things that I've noticed in my career as I monitor AI is every time someone says AI does X, but it cannot do Y. Okay, AI can beat the world chess champion today, but it'll never be able to do complex reasoning. A couple of years later, it's able to do complex reasoning, but it'll never be able to pass an eighth grade science exam. A couple of years later, it passes an eighth grade science exam. What I've noticed is that time constant between those, it can do this but can't do that, is shrinking over time, right? And so, I'm very bullish on AI and the ability to transform, have a profound impact on the way that companies in the United States operate, the way that we fight wars, the way that we live our lives.
Andrew, one of the terms that we hear a lot, both in talking with folks in primes, in the government, and at startups, is the term software-defined warfare. What does that term mean to you, and what role do you see for startups and primes within that future vision?
Yeah, okay. So this is an important one. One of the United States' enduring asymmetric advantages is we can innovate faster than anyone else in the world. Full stop. We innovate faster, and that's incredible for our ability to maintain an asymmetric advantage. So what does innovating faster look like in the midst of the fourth industrial revolution, right? It means deploying operational capabilities in microseconds, not months, right? And so we've got to go from months historically to minutes to microseconds. So software-defined warfare to me is all about that. How do we deploy new capabilities into the hands of the warfighter in microseconds, right? So real life. So a couple examples that I can give. The kill web has got to turn into code. And so this is where we've got, a sea of sensors that are out there looking for, nefarious objects. And then you've got a tremendous number of effectors, kinetic, non-kinetic effectors, and then the decision logic to connect those together. That decision logic has to optimize for a tremendous number of things in this. If you have a large number of heterogeneous incoming threats, when I say heterogeneous, I mean could be hypersonic, could be class 1 UAV, could be a cruise missile, and in cases that we've seen recently, it could be all of them simultaneously. And so what a modern mature kill web will be it'll sense the incoming threats and then optimize effectors for those incoming heterogeneous swarm so that you maximize your probability of kill at the lowest cost possible. So the cost curve is important. Okay, so to be able to do that and adapt. So as soon as we deploy a kill web, it will be obsolete, right? Because the adversary will immediately start to adapt, right? And so we have to be able to do over-the-air upgrades, right? And so things like radars, electronic attack modules, these sorts of things, we have to be able to update them with new techniques, new waveforms on the fly, so that we're able to act and react faster than any of the adversaries. I did want to give one real world example of software defined warfare. And so I'm going to pull on an exercise that was recently ran, Talisman Sabre. It's a joint exercise between the US and Australia and Indo-PACOM. The challenge there that they were trying to demonstrate, one of the challenges that they were trying to demonstrate at Talisman Sabre, and it's somewhere we've been doing a lot of work on with a product called Disco, is, currently from the time an adversary deploys a new, I'm going to call it an RF threat. So there's a new radar that we've never seen before, or or a new jammer that's trying to jam our communications. To the time that we detect that novel waveform, classify it, and then create a new electronic attack technique to get after that waveform currently takes months, right? And it's just far too slow, right? And so with Disco, what we've done is, the adversary comes up with a new jammer. We're able to detect, classify, and then create a new electronic attack technique or a new waveform on the fly, deploy that back to the edge platform in minutes. And we're targeting microseconds, right? So again, something that currently takes the US and our allies months, we're trying to tighten that up, minutes, microseconds in the electromagnetic domain.
That's great, Andrew. And something, we did in the past, right? During the Cold War. It was the blind man's bluff, so to speak, across all domains. But to your point, it's just getting faster, and the iterative process is just only accelerating. I had two questions on what you just mentioned, which I thought were great. The first is, you see AI and some of these novel technologies are not even novel these days. They're here, they're in the commercial space, they're trying to get applied, whether it is in the perception space from a computer vision standpoint or in the multimodal. But unlike startups, you have seen how this needs to get deployed at scale. What are startups missing when it comes to getting some of these software defined applications ready for production scale with, right, on thousands of camera balls or potentially hundreds of thousands of sensors, which is the ecosystem we should have?
Yeah, it's a great question. So one of the things that we focus on a lot at L3Harris, I'll call it missionizing capabilities. Missionizing capabilities. So one of the startups will come with a capability. It's a CSATS UAV. It's a small UAV about the size of a surfboard. How do you take that from, hey, this is a really capable platform and make it something that's going to be useful to the warfighter, right? And so now you've got to have resilient communications. You've got to have ISR assets, so intelligence, surveillance, and reconnaissance. So that's back to the EOIR balls that we talked about earlier, or SIGINT detectors, that sort of thing. And so one of L3Harris's sweet spots, and quite honestly, one of the reasons why we're so excited about working with the Shield Capital portfolio companies is our ability to work with the startup to operationalize and missionize their capabilities and get it into the hands of the warfighter. That goes for hardware, such as CSATs or Apex, which we're also working with. It goes for software as well. Overwatch Imaging is a good example. So, the DoD has, very specific rules of engagement in terms of how do you get authority to operate and things like that. And so really thinking through that pipeline from how do I go from an eye-watering world-class capability through the ATO process and all the while, having budget to do so.
Andrew, I wanted to ask you about Ukraine in particular. What are some of the lessons we should be learning from the conflict in Ukraine? And what are some lessons that we shouldn't be over-indexing on from this conflict?
Oh, that's awesome. Do learn and don't learn. Let's do that. And I think that's important because I think sometimes we overfitted from the Gulf Wars, and so let's not remake those mistakes where we overfit. So what have we learned, or have we relearned? I will also say from the war in Ukraine and the conflicts in the Middle East. So one, masked cheap autonomy can win. Right. For many years, it was all about exquisite low numbers of precision missiles and precision strike. We've seen first-person video drones, Shahed class systems. These are just because of the cost curve are a formidable challenge. So massed, affordable mass with autonomy folded in is certainly important. Electronic warfare, EW. So in layman's terms, this is the ability to jam, spoof, and survive in a contested spectrum every day. And it's decisive to modern warfare, right? Systems are being jammed in the Stone Age. And actually, the way that they're overcoming that with first-person video drones is, as you all know, they trail a fiber now, right? Because they're unable to communicate in these contested environments. I will say with, the right communications, with resilient communications, it is possible to burn through the jamming that the Russians have put out there. But the question is at what cost point, right? So these first-person video, I said they were cheap, right? And if you want to build a high-end radio that's going to burn through that, it's not going to work. Layered integrated missile defense, it works, but it must be affordable. So we've seen time and time again, whether it's Iran attacking Israel. Again, this was a heterogeneous strike with everything from drones to all kinds of missiles, right? Layered IMD, integrated air and missile defense, it absolutely works. And I think the United States and our allies are learning a lot about how to optimize these things for the current state of threats. But at what cost, right? We have to be able to continue to develop these capabilities in a way that puts a cost curve in our favor as opposed to our adversary's favor. Multi-million-dollar Standard Missile 3, Standard Missile 6 for a Shahed drone is not a sustainable answer. And so one of the things that we'll have to learn as a nation is how do we mix effects in an optimal way? So mixing effects, high power microwave, laser, free space optical laser, these sorts of things with your exquisite missile defense in a way that provides the highest assurance of keeping those critical assets safe. but at a cost point that we can survive. Next up, I'll say is maritime drones have absolutely changed the naval calculus and off the Crimea Peninsula. So if you've been tracking these low cost USVs, I think there were essentially missionized jet skis or missionized Sea-Doos. They're able to force a fleet of Russian ships to redeploy away from Crimea, and largely took a lot of the Russian ships out of the fight. Either a couple of them were destroyed, their flagship was destroyed, or they're pushed so far out. At the same time, we don't want to overlearn on this, because lessons learned in a relatively confined quarter such as the Black Sea don't translate to the Pacific and Indo-Pacific theater, right? And so we want to learn from that in some domains, maritime drones are critical. But if you're in a blue water fight, that, hey, you've probably got a different cut-up and different look. Okay, really quickly, what do we not want to learn? I've heard some rumblings that, hey, tanks and air power are obsolete. I do not believe that to be the case, right? That you still have to be able to deliver mass, lead on target. They're not dead, but they do die without electronic warfare cover, deception, combined arms integrated with a sensor saturated fight, right? And so if you deploy a tank out on an island, it will die, but you provide the EW and the ecosystem around it. It's still a part of modern land warfare, I think. And then, of course, exquisite beats many. I think an over-reliance on exquisite platforms, we've definitely learned that that's brittle against cheap mass and EW. But that doesn't mean we should go all the way from exquisite, right? That means we have to have a balanced portfolio of high-end exquisite weapons and the lower end, less capable, but also much more cost-effective weapons. And then the key to all this, and we've talked about this, is the intelligent C2, which allows you to combine those effects in a way that's going to keep things safe at the lowest cost possible.
Thanks, Andrew. You talk a lot about some great lessons there, both the ones that we should emphasize and not. There's a lot of learning lessons, and then there's acting upon those lessons and actually being able to implement those at scale. To you, what are some really good success stories that you hold in high bar from past history where either the US or maybe it wasn't the US were able to quickly really internalize that lesson and then field what was needed from a technology standpoint, integrated with what the users and operators needed?
Yeah, it's a good question, and we are on a modern podcast here, but I want to go back to the United States has been doing this for a long time. Back in the early 2000s, the United States was fighting wars in the Middle East, right? And one of the biggest issues was IEDs, improvised explosive devices, were having an outsized toll on American and Allied soldiers and sailors. And so I know that the U.S. Army had a huge effort to go out there and understand, what is this threat doing? How is it providing such an impact on our soldiers in the field? And what they did is they deployed the MRAP, right? It's a mine-resistant ambush protection system, right? So it's basically like a boat, right? And so that when one of these IEDs blows up, it vectors the force of that explosion off the side of the hull. Super interesting how they did it. But I know that it's probably one of the fastest acquisitions of a major platform the U.S. has done in decades, right? And so the point is there are all these new RCOs, rapid capability offices. There's DIU doing excellent work out of DIU. But the United States has been doing this. And when it comes to sailors or soldiers whose life are in harm's way, we absolutely figure out a way to get it done. I do see OTAs, other transactional authorities, as a great way to move fast. And the United States, while it's been codified in law for a while, the ability to use OTAs, the department is expanding their use of OTAs specifically by commercial platforms, right? And actually, this is one of the places where L3Harris really, really likes to partner, right? So the U.S. says, that the Defense Department says, we want to buy UAVs, commercial UAVs. We want to buy commercial drones. We want to buy, these commercial things. But there's still got to be someone who really knows how to take that commercial thing. In fact, Joby is a great example of, they make these commercial, what would you call them, Maggie or Akil? Not a quadcopter. They're a helicopter, multi-propeller.
Flying cars.
Yeah, flying cars. Thank you. Yeah.
As close to the Jetsons world as you can.
Exactly right. So Joby's super innovative company. They build these commercial flying cars. And when we talked to Joby initially, we said, hey, this is an awesome platform that can bring a lot of capability to the warfighter. We would love to work with you, Joby, to figure out how do we put resilient comms in here so that as soon as the adversary turns on the jammers, we're able to still establish command and control. How do we put ISR assets on there, intelligence, surveillance, and reconnaissance? How do we put things like EW payloads on there, electronic warfare? And so that's where, a partnership between, folks like Joby or, more broadly commercial capabilities can work with L3Harris through an OTA to get capabilities, really eye-watering capabilities in the hands of the warfighter more quickly.
Well, thanks, Andrew. I will say on the MREP note, referencing Secretary Gates's book, it did sort of take the secretary to emphasize and prioritize initiatives like that. Hopefully things have changed. And I'd be curious, on your perspective, have you seen structurally sitting where you are now, right? Like looking for the demand signal, not just the demand signal, you see it from the operator perspective because you're staying in touch with what is happening there. You're seeing how your technology is being used, where the limits are. And then you're seeing a demand signal from those voices that matter. Has it improved and evolved in the way that you would like it to in the last 20 years?
Yeah, absolutely. So it is interesting. So, at the end of the Cold War, the United States and our allies had a peace dividend, right? And, we built an acquisition system over the years that was really focused on delivering a peacetime military, right? What's happened is, the increasingly assertive China and a major land war in Europe that, quite frankly, a few years ago was unthinkable. And so I think it has forced us all to take a step back and look at, is the acquisition system as it's structured today, what we need to, not just because the threat's changing, but the technology is changing so incredibly quickly, right? I think, to me, people ask, isn't the fourth industrial revolution, just another, technology? Why is it actually industrial revolution? I think it's the pace of change that really drives, to me, why it's a profound impact to the United States and our allies.
Andrew, speaking of some of these acquisition trends, one of the big buzzwords that we hear with respect to acquisitions and the DoD budget is Golden Dome. I know that L3Harris is really working in the sensor space and the space. Would love to get your take on what exactly is Golden Dome. What does that mean in the first place? And where are you seeing opportunities for startups developing new technologies?
Yeah, absolutely. So Golden Dome, super exciting new. As a technologist, super exciting. I think also super important from a national homeland defense perspective as well. So I think the architecture for Golden Dome is still taking shape, or if it has taken shape, I haven't seen it yet. But we know broadly what it looks like and what it will, the functions that it will have to be able to do, regardless of the architecture, right? And so a key part of this is being able to that the earlier you can detect a threat, and not just one threat, many threats, the better. And so this is going to drive space sensing and custody, right? And so you'll see a proliferation of LEO and MEO, low Earth and medium Earth orbit, persistent tracking, on orbit fusion, and the crosslinks to do all that. So I said on orbit fusion. I think that's really important. So historically, if you didn't have to operate on timelines that included hypersonics and that sort of thing, and reacted machine speed, you would be able to have an on-orbit sensor sense, hey, there's a missile launching over in this bad space over here. Pipe that information down to ground station, process it, and then figure out what you're going to do about it. Quite honestly, that's just too slow. And so there is going to have to be an ability to deploy things like automatic target recognition to space so that you're able to close that kill chain more quickly. Crosslinks are really important because preferably we'll have multiple assets tracking these missile launches, and you can improve your probability of detection, your probability of correct classification by fusing all this data together. And so we'll see things like optical crosslinks, which are incredibly high data rate, continue to proliferate, so that we're doing this on-orbit fusion, classification, detection, etc. We talked about battle management, command and control a little bit earlier. Maybe in the counter UAS scenario. But same thing goes for the Golden Dome, right? So Golden Dome, you've got to have a high assurance data fabric. The foundation of that will probably be things like optical crosslinks, and that is the physical layer for the data fabric. Once you have that data fabric, you've got to be able to do the AI-assisted track correlation, discrimination. And these are easy problems if there's one bird in the air. But imagine now that there are thousands, right? And some of them are hypersonic, some of them are decoys, some of them are UAVs with warheads on them. And so that's why you need to start to use these AI-assisted tracking correlation to really discriminate between what's a threat, what's a decoy, and what's civilian air traffic, for instance. And then once you've got all that, you're connecting all this data together, and you're fusing it, and you're saying, hey, these are the tracks that I need to prioritize. You've got to be able to pair those with shooter pairing at a continental scale, right? And so this isn't just a theater anymore. We're protecting the entire continental United States, Alaska, and Hawaii, and hopefully all of North America, right? And so being able to do that sensor shooter pairing is a non-trivial problem, even for AI, right? Especially in an environment so incredibly high state space, sometimes unreliable information, right? Because your track quality can be varying, right? There's decoys. It's quite honestly just the fog of war. Okay, so you've got to be able to sense and track. You've got to be able to do the sensor shooter pairing. You've got to be able to once you've paired it to a shooter, we can't afford to have hundreds of millions of dollars of shooters for each shooter to be super expensive, right? So we've got to have an affordable effector stack, right? So that does include hit to kill, right? We will have to hit a bullet with a bullet. I believe longer term, we're also going to have more cost-effective layers, right? So we're going to have high power microwave. We're going to have lasers, particularly for counter UAS and counter cruise missile saturation, and so that you're able to use the lower cost effectors and also lower cost interceptors for the volume, and then you save your really high-end interceptors for those exquisite threats, right? And of course, underlying all this, resilient comms, PNT, so pointing, navigation, and tracking, all incredibly important. I can't underestimate the importance of resilient comms, and I have noticed, maybe back to your question, Maggie, about what did we learn, and what do we not want to overfit on? I think one of the things that we overfit on from the Gulf Wars is we'll always have electromagnetic superiority, which means we'll always be able to communicate uncontested, right? That's not going to be the case. And we've seen this in the Ukraine wars. We are going to have to have resilient communications, which means it's spread spectrum, frequency hopping, that sort of thing, incredibly high end to be able to maintain that communications. Last thing I want to mention, I'm an engineer, so I've got to mention some engineering. We got to have digital engineering and test. And so this gets to the ability to iterate more quickly, right? And so national scale digital twins so that we can do everything from probably the most interesting use case of a national level digital twin of all this is to train, perhaps via reinforcement learning, the sensor shooter pairing, right? You only get one chance to do this in real life. So to train these algorithms, you'll need to run it, millions, trillions of time in simulation, right? Okay, so you asked me how startups can plug in. Tremendous opportunities for startups to plug in. And I know at L3Harris, we're looking for startups to plug in. Everywhere we're plugged into Golden Dome. So data and AI, obviously, right? So, one of the things that people, probably all the people on your podcast know that, AI starts and ends with data, right? And access to data. But gosh, to the extent that startups are able to, build capabilities to do sensor fusion, discrimination. These can be microservices within a broader architecture, right? Particularly with, we can help provide real data sets and that sort of thing so that you can train. Non-kinetic effectors, right? Things like high power microwave. There are a couple startups that are actively involved in high power microwave. Things like Gosh, I want to sound a little bit like Austin Powers and, or I guess this is Mr. Evil, lasers on sharks, right? I think, things like high power energy, in terms of like laser, are going to be increasingly important. So what does that mean in startup world? There might be startups with high power laser capabilities, but gosh, there's a whole system that has to go around that to be able to actually use it. So example I'll use is beam directors, right? These are things that if you've got a high power laser, you've got then a mirror with basically a steerable beam director that you use to point at the target, right? Digital test ranges, manufacturing tech, there's just opportunity across the ecosystem.
Andrew, so many awesome things right there. I don't even know where to start. Let me dive into a couple of them. Let me start with SCA. You mentioned a little bit of the comm resilient piece. To you, is that Golden Dome is not new in concept, right? We've been talking about, I think The Economist ran a piece comparing Star Wars to Golden Dome. What has fundamentally changed that might make Golden Dome different today? And is the long pole in the tent, from your standpoint, technology, the resilient comms, or something else?
No, so I think we have all the technology to build Golden Dome today. That is true. We have everything from solid rocket motors that, perhaps could survive in space. So that's material advancements, to the sensors that we need to be able to detect these things. So really, it's a monumental engineering effort is really what it is, to be able to create a missile defense system that covers, a continent, right? It's really, to me, it's like, probably the ninth wonder of the world, right? And so the technology is there. It's, how do we integrate that? And it's kind of like the space race. It took the will of a president in the space race to get to the moon. I think similarly here, it will take, the will of a president to drive this thing.
Thanks, Andrew. And on that note, you talk about digital twins, which I think is this beautiful nexus, right, between the physical and digital world. Can you actually unpack a little bit about what do you mean by digital twin? I mean, in the news at least, right, you hear about the B-21 Raider being designed in the digital world. At the same time, I feel like a lot of us, from having served or just generally or have worked in the automotive space, know that at some point you kind of just got to get the thing out there in the world because you're not going to be able to model this all. How are you all kind of thinking about that?
Yeah, a couple things. So, to the extent that we can use digital twins to move faster so that you don't have to, so that you can take your lumps in, ones and zeros versus in hardware and have to completely redesign it. I think that's where we like to focus a lot, right? So, we are laser focused at L3Harris at moving faster. Like I said, the Navy and the other services that the fight is tonight. And so that's how we use digital twins. I will say that the most exciting place for me in terms of, digital twin and simulation are around, how we can use it for training and fine tuning AI models. And so an example that I'll give is in the RF space. So cognitive EW is increasingly important. Any waveform that you deploy, whether it's a radar or comms waveform, the adversary is going to figure out how to jam it, and they're deploying cognitive EW so that they can figure out how to jam it incredibly quickly. And so we as a nation have to be really good at generating new waveforms, generating new EA, EW techniques, et cetera, et cetera. And so, back to digital twins, I think as a nation, we probably need to set up a electronic warfare simulation environment, right? And so the way this would work is, and what our goal is to be able to create AI agents for EM superiority, electromagnetic superiority. And so if you've got a model that you want to fine tune for, this complex space where you're doing electromagnetic battle management, so you've got to be able to communicate while your adversary is jamming you and they're trying to adapt and you're trying to adapt. You want to have basically an EM playground, right? But with as complex as EM propagation is, you can never, ever, ever train a model at full fidelity. Even with, future computing, you'll never be able to do that. And so what we're going to have is a digital twin with varying resolution. And you start off with incredibly gross resolution in terms of the simulation environment and use that to get a gross training of your model. You run that, 1 trillion times, right? 10 to the big number of times, right? Then you turn up the resolution by a factor of 10 and you fine tune. Turn up the resolution by a factor of 10 and you fine tune. And so you take this model that was very gross and it's do you remember how AlphaGo Zero was trained? Yeah, and so the very first generation of chess playing AI was basically a bunch of data scientists who hand coded things, and they were teaching it techniques, and it was very labor intensive, right? And then they were like, hey, you know what? A more interesting way to do this would be to have one AI agent play chess against another AI agent, and they didn't even tell it the rules of the game. And very quickly and very rapidly, it was able to run these games against itself a trillion times. And, now my iPhone can beat, probably the best players in chess, right? Because of this reinforcement learning in a simulated environment. So being able to do the same thing in the RF space, I think is going to be increasingly important as we move into, cognitive EW, cognitive comms, cognitive warfare.
Thanks, Andrew. Real quick, for those who aren't as steeped in EW, what is cognitive EW?
Yeah, so cognitive EW, so it can mean a number of things. Very roughly, a waveform is the way that I communicate in the RF spectrum, the way that I communicate with you. So FM radio, that's an example of a particular waveform, right? AM radio is another waveform. 5G is another waveform. Right? It's actually a suite of waveforms, right? Cognitive waveforms can mean a number of different things. You can think of it in levels, right? So a cognitive waveform that is relatively basic would be a cognitive frequency hopper. And so this is an example of where let's imagine, Maggie, I'm communicating you on a certain frequency with you on a certain frequency. 1 megahertz, for instance, right? It's not a good frequency, but let's imagine someone starts to jam 1 megahertz. I'm going to jump to 2 megahertz. Someone starts to jam that. I jump back to 1. They're still there. I'm going to jump to 3, right? And so, sort of the most basic cognitive EW is things like having clever ways to do frequency hopping and clever ways to do your modulation. I'm going to switch from AM to FM, for instance. That would be your lowest level cognitive waveform. Some of the more high-end stuff, let's call it generative waveforms. You can create the waveform on the fly, just like generative AI creates a poem on the fly that is optimized for whatever you want to optimize for in this space. So you can say, hey, I want to optimize for throughput given this specific jamming environment, right? Or you can say, hey, you know what? I want to mimic, right? So I want to mimic 5G. I want to mimic Wi-Fi and sort of hide in the noise. And so because generative waveforms, and this is the most advanced AI, you're able to change the objective function. You can do sort of limitless things with it. I have seen tests where these cognitive waveforms are able to outperform classical waveforms in very, very, very harsh jamming environments. Now, the reason they aren't deployed right now to the edge is they're very incredibly compute intensive, right? To do this, it takes quite a bit of compute. But as compute cost comes down, I expect to see these things being deployed more and more, probably first through SOCOM and some of those early adopters, and then as compute cost continues to come down, we'll see more and more cognitive waveforms, cognitive VW, deployed to the broader US DoD.
Andrew, I want to shift gears a little bit and specifically talk about how you view startup defense prime collaboration. I know L3Harris has really been a leader in this. This has become a big part of your strategy as the trusted disruptor in the defense space. So maybe the first question I'll ask, where do you see opportunities for startups to really excel versus what kinds of technology areas do you think that defense primes will continue to remain dominant in?
Yeah. So, and I will say, I do think, defense primes, and where I put all of my cycles as the CTO of L3Harris, is around operationalizing AI. There's some really interesting space here where, the U.S. technology ecosystem, including, venture capital backed companies, can work with the sort of the larger primes. Why is this a good marriage, right? So, when we look at what L3Harris is really, really good at, we have exquisite domain expertise, right? We spend a lot of time in customer spaces understanding what are their hardest challenges. We tend to have access to a lot of data. We build EO/IR balls, we build radars, we build radios. And so all this data are things that we can use to take a model that has been developed, a capability that's been developed by potentially a startup or a partner, and fine tune that for a mission application. And the final thing that we have as defense primes. Let's see, we covered Oh, real estate. So I helped stand up and was a part of, one of the premier divisions in the National Lab System that does AI. It's the AI and Data Analytics Division at Pacific Northwest National Labs. And so they're great at AI for national security and high consequence environments. They have some of the world's best data scientists and data engineers. What is their challenge? Their challenge is, access to real estate, access to operational systems, right? And so if you've got models, whether they're coming out of the national labs or whether they're coming out of the venture tech ecosystem, you have to have places to actually deploy those so that you can start to have an impact on the warfighter or missionizing AI. We talked a little bit about this earlier, but we've got these EOIR balls, lots of data coming off them. How do we provide more value? That means we need to be really good at okay, so this is a use case. We think it's probably an AI/ML use case. Not every use case is AI/ML. We've got to be really good at selecting the right model, right? And so that gets to which startup or open source model or partner model do we want to adopt? How do we fine tune that model with real operational data, and then how do we get it through the ATO process so that we can actually deploy it, right? Deploy it to the edge. And that's one other part is the deployment to the edge is sometimes non-trivial. And this is somewhere where slight digression here, where CodeMetal is actually helping us, right? So it's pretty easy to deploy AI to GPUs, right? It's less easy if you're in a SWaP-C, so size, weight, power, and cost constrained environment, potentially with only access to FPGAs. And so, these things need to be very power conscious because you're on the edge. You're on like a radio that, a soldier has to carry for 10 hours and not 10 hours, 10 days. And it has to, operate for those 10 days. Imagine if your iPhone lasted for 10 days, I would be much happier. And so CodeMetal actually helps us translate code from, say, Python, MATLAB into embedded code on the edge, right? FPGAs, that sort of thing. Okay, so that's where primes are focusing. L3Harris and my peers and the other primes are really focused on operationalizing AI. I think that the startups, so I mentioned CodeMetal, that's a really interesting use case, model translation, but novel AI ML, right? Edge autonomy stacks, synthetic data generation. These are all spaces where, there've been tremendous commercial investments in Silicon Valley and the US DoD, or I'm sorry, in the US technology ecosystem. And those are places where, if you've got novel models, particularly models that you think would be amenable to SWaP-C, size, weight, power, cost environments, then hey, those are places where, we'd love to talk to you and figure out how we can, start the process of missionizing and operationalizing.
Andrew, how do you all determine when you're going to partner with another company or startup versus when you're going to build some of that technology in-house? I know L3Harris has 10,000 engineers or something employed.
20,000 engineers. Yeah. And so it's a good question. All right. So we would always rather accelerate, right? And so the way that I look at it, partnerships with startups is, we have technology roadmaps, and our technology roadmaps, actually don't start with technology. If anybody starts talking to you about technology for a technology roadmap, they're wrong, right? You start with a mission, right? These are the hard problems that we L3Harris want to be able to contribute to, right? So that's one end of the bound. The other end is what technology do we have today, right? So this is, L3Harris capabilities that we have today. From that, I've got two endpoints, right? I've got the mission we're trying to solve, the customer problem, and the technology we have today. That's the gap. If there is a company that can accelerate the closure of that gap, then I absolutely want to talk to them today, right?
What do you see startups most misunderstand about working with a large defense prime like L3Harris?
Yeah, I think there's, sometimes misperception that large defense primes don't want to go fast, right? And, to be honest, a company as large as L3Harris, we're not a monolith, right? And there are parts that will still be slow. But by and large, we care about exactly the same things as everyone else in this ecosystem, right? We want to go fast and solve hard problems. From the flip side, if I take that question from the flip side, I get a lot of misperceptions from my engineers about startups, right? And so some of the misperceptions that they have is many times engineers, particularly if they've never worked in a startup, see a startup almost as a supplier, right? And so the startup will bring a widget and the engineer will say, hey, this is 5 degrees from the widget that I needed. Sorry, don't want to talk to you. Whereas what they don't realize is, hey, you know what? If I just engage a little bit with the startup, they would be more than happy on an incredibly short time frame to shift that 5 degrees and build something that is absolutely 100% applicable to the problem I'm trying to solve, that gap that I'm trying to close, right? And so, a lot of my internal work at L3Harris is just helping engineers understand, hey, you know what? You've got to invest and you've got to invest your time in startups so that they understand the problem that you're really trying to solve. And you also have to be conscious of their time horizon, right? If you've got a pursuit that, hey, it's going to be palmed in 3 years and you'll finally get money for it in 8 years, that is not an appropriate place to engage a startup, right? So we have to be aware of, hey, what are the problems that are amenable to startups in terms of what a startup's traditional run rate is.
What advice do you have for startups to work with a company like L3Harris? Like, what can a startup do well, or what have you seen startups do well? Sort of the flip question to what I asked before, which is what do they not do well?
Yeah, agreed. So startups that do well, this is sort of the flip-on answer, are, they're adaptable and willing to fit into, and I'm not going to say the L3Harris need, but the customer and mission need, right? And so I think that adaptability is incredibly important. I think that's actually inherent in most startups' DNA is, they don't run Agile. If you talk to a founder about Agile, they'd hit you, right? It is pivot until you find that product market fit. I would advise, hey, startups need to not confuse a great demo with a deployable capability. So you've got to understand your concept of operations, but also your concept of employment, right? And so to give us a call, and we will help you understand, hey, what's the concept of employment? A lot of startups don't have access to SCIFs and high side information, right? So we can help shape in appropriate ways, shape your product so that it's actually solving the problem that the warfighter has. It's actually addressing the threat that they're facing, right?
Thanks, Andrew. Maybe a little bit, flip it again. You look at it, there's a perception that exists, I think, in certain spaces that, the primes are like the evil eye of Sauron. They've existed for a while, they're there. But I think there is this interest of startups to some of the points you bring. There's also some real value of finding the right partnerships at the right time and place to achieve effects ultimately for the mission. I guess my question is, if you're a startup, how should a startup be evaluating and what should they be expecting out of a partnership with someone that's a lot bigger than them, that may have a direct relationship with the customer when even the startup wants to have that direct customer feedback engagement, and then be able to navigate what is limited time for a young startup in finding which partnerships make sense and which one are actually going to drive value across both organizations and, to your point, ultimately for those who need it the most from a mission standpoint.
Yeah, absolutely. And so I think here, looking for partners who are interested in a true strategic partnership as opposed to a transactional relationship, I think is really important. So, when you talk to, various primes, make sure that they're willing to invest their time in you. And so I'll give you an example. At L3Harris, we have internal money that we use to run things that we call validation projects. And so if you come, Akil, you've got a novel widget that you've invented or, a software app. We invest our own money at L3Harris to figure out how that app can be used to fill one of those gaps that I talked about to solve a hard customer need, right? And so that's an example of a strategic relationship where, we're investing in the relationship, you're investing in the relationship, and together we're able to move faster and solve harder problems that we'd be able to do individually, right? And so I'm really looking for that. I often, a lot of times when primes engage with startups, and I haven't seen this at L3Harris, but I have seen it, they want to be a bully around IP rights, right? Like, we want to own IP rights. And what they don't realize is that just absolutely kills the startup, right? It makes them unappealing to investors and that sort of thing. And so watching your IP rights, make sure that, the prime that you're working with is looking to generate mutual value. Mutual value, I mean, for the prime, for the startup, and for the customer, and not just for themselves, right?
If you had all the CEOs and CTOs, senior leadership of other large defense government contractors in a room, what advice would you give them?
Yeah, so I think the first thing is definitely focus on open systems, right? And so the reason this is important is, I said earlier that, the United States, our asymmetric advantage is our ability to innovate faster. And actually open systems, while they take a bit more time upfront, really open up the architecture and the backend, right? So if some startup comes up with a new capability, because it's an open architecture, man, they'll be able to plug that into this architecture, quickly get it operationalized and make a real difference, right? Whereas if we have a closed ecosystem with, everybody owns their own IP and data rights, nothing plays well with each other, we're never going to get to that future where we're able to rapidly deploy capabilities and iterate more quickly than our adversaries.
Andrew, maybe one level deeper on the open architecture. Is the government providing the right incentives for that ecosystem? And what would be the one policy change that you would have? Because I think folks think about modular open architecture, but folks are also trying to make a business and have it be defendable and not be on a year to year or trying to figure out whether their system's going to survive or not. And so I think there is this healthy tension between what can you defend on the company side, but still provide the value and create the incentive structure you would need to do that correctly.
Yeah, I mean, I would say I'm never worried about defending anything. If you have to defend based on a closed architecture, then you're not moving fast enough, right? And so our strategy is to continue to move faster than anybody can adopt it, and we will continue to have and also really understand where you make your money. You make your money off of your implementation of the open architecture, right? And so waveforms, we've talked a lot about like communications. Waveforms, many of the waveforms are open, right? They are government-owned protocols. That doesn't mean that L3Harris doesn't make money off it, right? So we still take that waveform and translate it into software, implement it on hardware, and sell an operational capability. And so open architecture doesn't mean you can't make money. I think, what we need more of out of our customers is just consistency, right? And so probably 90% of the customers are out there saying open architecture, open architecture, open architecture. There's a vocal 10% that will say, well, gosh, with closed architectures, we can go faster, right? Because they see the upfront initial investment, which is, gosh, you're maybe 10% slower as the overall impediment. But let's look at like a concrete example. We talked about tanks earlier, right? You could create a tank that is a complete closed system, right? Like you don't allow anybody to plug in a new EOIR ball. Nobody can plug in a new comms module, that sort of thing. You can do that faster, right? You can just go deploy a closed ecosystem today, right? Now, let's say you spent a little more time and you built this thing on an open architecture, which means you can switch out modules, right? So as a new radio comes online, one of these cognitive radios or cognitive EW comes on, you just take out the old one and you put in the new one. This could come from startup ecosystem. It could come from a traditional defense contractor. A new radio comes online, a new EOR ball comes online, right? And so it allows a much faster upgrade cycle, right? And so, in this tank example, you can see how, yes, the proponents of closed systems were right that you can, get a fixed capability to the field more quickly.
What's a technology that you are bearish on in the short term, but bullish on in the long term?
All right. I did mention high energy lasers and HPM earlier. There is still a way to go before those are real operational capabilities. I think everyone's seen there's been a couple of interesting prototypes and examples where people have shown, hey, we're able to, kill a UAV or, some other interesting things. So today, weather, power, beam control, these are the limiting factors. In the future, these will be indispensable for a layered, cost-effective defense. The other is quantum. So quantum, people think about quantum tends to be in three buckets. Quantum sensing, quantum communications and networking, and quantum computing, right? At some point, quantum sensing, such as Rydberg atoms, are going to be far outperform RF antennas, RF capabilities for doing sensing for comms and SIGINT. In the near term, though, I don't see an impact in the next 5 or 6 years. So again, bearish in the near term, but long term, these things are going to be differentiators and game changers.
And then I know you've been in the national security technology space for decades now. What's a technology that you thought would be further developed than it actually is today, back in your days at MIT or one of the labs or elsewhere?
The technology that I thought would be further along is true CJAD C2. For those of you in this field for a while, It was net-centric warfare before CJAD C2, and before that it was something different, right? And so, we still fight in data silos with bespoke messages more than we should, right? And so really being able to bring that any sensor in every shooter, every sensor in any shooter capability to the battlefield, I thought we'd be further along. It's been a huge focus for the DoD for at least 2 decades, and I hope we continue to make progress around true CJAD C2. Less developed, but pleasantly surprised. Autonomy at the edge. So small teams are absolutely deploying incredible capabilities. Everything from, we talked about Overwatch AI to Shield AI, to, not to be confused with Shield Capital, that happens. Overland AI, just incredible advances in terms of true autonomy at the edge.
What are some tech areas where our adversaries are ahead of us in developing and deploying, and what will it take for the U.S. to catch up?
One place I'll point out is hypersonics and long-range strike. So PRC, Russia, munitions like the DF-17. I will say that the United States, and we here at L3Harris Aerojet Rocketdyne, have eye-watering, exquisite hypersonic capabilities, right? And the ability to do computational fluid dynamics, advanced materials. And the United States does have some incredible hypersonic capability. That said, deployed operational hypersonics, we are behind. We are absolutely behind. And so that's the space where we'll want to keep up. Shipbuilding and just the industrial scale and the industrial might that China is able to bring to the table. We currently... Our fleet growth is just being outpaced by large numbers. Tactical electronic warfare. Actually, I'll lump these next two together. Tactical electronic warfare and low-cost drone ecosystems. Currently, Russia is beating us there, and it's largely because they're actively engaged in a war in Ukraine. What this does for them is it's tightened their learning loop, right? They deploy an EW technique, an EW system. It doesn't work. They are forced, they are currently forced to continue to update and cycle that. Whereas, our EW capabilities aren't nearly on the war footing quite that Russia is.
Thanks, Andrew. I want to end where we started with you being a technologist. And if you had 1 extra hour in your busy day, you've got a ton of things. You got the leadership aspects to run the organization. You've got the connecting the dots piece. And then somewhere in there too, you get a chance to vibe code. What would you spend that extra hour that you would have to do, and how would you kind of break that apart?
I think as technologists, it's easy to become enamored with the technology. And I spend an incredible amount of time, like I said, even developing my own models. If I had an extra hour, I would spend the time with the operators, with the people who are actually using the technology. Because at the end of the day, as a CTO and a technologist at L3Harris, I believe every engineer at L3Harris, we're here to solve hard customer problems. And so the better understanding that I can have and that every engineer can have of what those problems are and how we might be able to solve them more creatively, the better, right? And so, I was recently talking with a customer and they said, "Hey, Andrew, I just need more bandwidth. I need more throughput on these radios." And we talked for a little bit, and it turns out that that's not actually what the customer needed. They needed the right information at the right place at the right time, right? And so that drives you to, yes, I could give you a radio with a bigger power amplifier and make this poor soldier carry around a big dish antenna. Yes, that could be a solution to that problem. But because we sat down and we talked and we understood the problem and the threat that they were facing, it actually, it turns out that the right answer is deploying intelligent agents to the radios to prioritize the data so they're getting the right information at the right time to provide decision and information advantage, right? And so more time with the customer, more time understanding what they're facing, what their threats look like, so that we can solve better solutions is where I'd spend my time.
Awesome, Andrew. Thanks so much for joining us. Love the conversation and look forward to getting back together and either talking about models or objective functions at the next time we can.
Looking forward to it. Thanks both.
Thanks so much, Andrew.
Hey, everyone. Thanks for listening to the Mission Matters podcast from Shield Capital. Tune in again next month for another conversation with founders building for a mission that matters. And if you yourself are looking to build in the national security space, please reach out to us.